I got to connect. Then once we get live, it'll connect, and then I have to set it up on.
All right.
All right. So we're going live on YouTube. All right. Let me mute something. All right. All right. I would like to welcome everyone to the August DevOps Online Meetup. I'm your host, Tom Henriksen, and I would like to welcome Prasanjit Singh to the August edition of the DevOps Online Meetup. So just want to let everyone know before I turn it over, we are having a giveaway for a DevOps handbook. So we have one of our attendees, and I will drop this in the chat so you can go ahead and fill out the form. But with that, Prasanjit, why don't you introduce yourself to the people here at the DevOps Online Meetup?
Sure, Tom. Thanks for having me. And my name is Prasanjit Singh, and I am the Director of Cloud and DevOps at Stars Play Dubai. So we are a video streaming company, and we provide on-demand movie series and all that. So basically, my role is centered around providing the infrastructure support here and advocating DevOps practices. So that's pretty much what I do. I own the DevOps and infrastructure for Stars Play.
So if you want to go in and just go in and start your presentation, and then, like I said, what I will do, I will moderate the chat. If anyone has any questions, feel free, but he'll start his presentation. Just go ahead, and then,
Sure.
Like I said, I'll chime in if there's any questions in the chat. Sound good?
Thanks, Tom. All right. So let me share my screen. All right, here we go. Okay, so what are we going to discuss today? We are actually going to discuss about continuous delivery and focus on how to measure continuous delivery. So that is what we are going to do. So most of you who are in the DevOps field or who are acquainted with software delivery would have heard about CI/CD, continuous delivery. So when we follow DevOps practices, we normally just focus on how to build pipelines, how to automate things, and how to deploy fast. So our focus is mostly on performance and velocity of the pipeline. So when we talk about performance and velocity, there should be a metric that tells us whether we are on the correct path or not. So in order to do that, we measure these pipelines and we see how efficient they are. So how do we do that? That's what today's discussion is about. So a little bit about me. As I already said, I'm a Director of Cloud and DevOps at Stars Play. I also love to teach, so I have created some courses at Coursera. So I have some courses about cloud and containers at Coursera. You can check that out. And I'm a AWS community builder. I speak at various conferences and I published a couple of journal papers on cloud and auto scaling. And I also have a YouTube channel, BinPipe, and there I post some of these videos, like how to deploy things or things I learn or pick up from others. I try to just create a video and put it up there so that I do not forget and I can refer to it at least later on, and others can also do the same. All right, so where are we headed? We'll first go on and understand what continuous delivery is, and we'll understand the key concepts around it, and we'll understand about an organization that sets up standards for continuous delivery that is called DORA. So that's what we are going to do to begin with, and then we'll understand the need of measuring continuous delivery and appreciate how it measures or helps us to measure DevOps success, and we'll see how these metrics are calculated, what are the key parameters that we have to get to in order to calculate these metrics. And finally, how can we represent these metrics to make it easily understandable for everyone, because not everyone will be good with numbers, some will like to visualize it. So we can put these metrics into dashboards or spreadsheets. So there are lots of ways you can represent the concepts. So that is what we are going to understand today. Well, so most of us know about this term DevOps, but this means different things to different people. Like for some, it is just dev and the operations team working together, or people with skill sets of both overlapping both dev and ops, so they can do both. So some people say DevOps is just a role where that person can do a little bit of development as well as knows how to deploy it on servers, knows Linux, so that's a DevOps guy. Some people say no, DevOps is a culture, like it is about how to deliver software from the time it is created to the time it is deployed and made available to the end user. So there are various ways to see into it. So let me just cover it briefly. So what is DevOps? In simple terms, it is a set of practices. It's not a certain role, actually. It's a set of practices that you follow in order to achieve two things. To break it down very simply, to be performant, like to deliver software fast, and to deliver software reliably, so that you don't have errors, make minimum mistakes. And even if you do, you learn from that mistake fast and quickly get back to deliver the newer version. So it is those set of practices. Well, so it is a full life cycle investment. By life cycle investment, I mean when we write code and we commit it into a repository, right from that time, a continuous life cycle starts up if we follow the DevOps practices. So therein, as soon as the code is put into the repository, we can trigger certain scripts or pipelines which will build that code, and then it will test that code. And if the test cases pass, it will deploy that code into a environment, production or staging or whatever environment it is supposed to be delivered into. So this entire life cycle is what that is what is encompasses the DevOps practices. And then DevOps is also a team undertaking, like all the people follow a set of practices, and it's not for just the developers or operations team or the quality assurance team to follow. It is a set of practices that people follow in order to deliver software seamlessly. And DevOps enables better delivery practices, as I said, and accelerates the last mile of continuous delivery. By that, I mean, once the code is compiled and built and tested, DevOps practices also allow you to deploy that code into your production environments, and at the same time monitor the code and get feedback about how the code is performing once it is live. For example, if users are seeing errors after a deployment, those errors would be continuously monitored, and those feedback would be passed on back to the development team. So you quickly know how your code is performing up there in production. So this works, I mean, keeps on happening in a loop. So DevOps practices are represented mostly by infinity symbol, you will see. So we call that the infinity model, where you keep on pushing code, keep on building it, keep on testing it, keep on deploying it, and back to your keep on writing new code again. So that is what DevOps is. Now, what is CI/CD? With the same theme, proceeding with the same theme, like if we represent it linearly, like the steps that are going on. So we begin with writing code, building, integrating it with the existing code that was already up there, and then releasing a newer version, doing some tests in the process, and then finally deploying. This entire series of steps is called continuous deployment, because you're writing code and continuously deploying it in the end. However, this series can be further broken down into smaller steps or milestones. So if you just code, build, and then integrate it into a newer version, that step is called continuous integration. So there are companies who follow practices of CI, but the CD part is manual. So you commit code into the repository, that triggers a build, and the build is then finally integrated with the existing code and tagged into a certain number. And this, that is all how it is automated that far. Beyond that, the deployments are done manually by operations team. So that is called continuous integration, where you continuously build code from different developers, committing into your common repository continuously, and that process is automated. Now, if you have a delivery part in the same pipeline, then as soon as the code continuous integration step is completed, and you have your test cases running there, and if the test cases pass, you tag that particular code and which has been built now into an artifact. Say you're working on a Java code, so you have your Java code in your repository. Now say you have a Gradle or Maven to build it, and once you build, you get your artifacts up there stored in some repository, the jar files. Now you can version those jar files and then release it. So if you get until this step, then it is about continuous delivery. So you're delivering a newer version, and all these steps are automated, happening with some CI server, like say Jenkins, or using any other CI server. Like there are lots of newer ones nowadays, Argo CD, then we have something called Drone, and so on. And also the cloud providers are also providing these CI tools, like Amazon has Code Deploy, and so on. So that is about continuous delivery. And when you add some steps where you can deploy your code, say for example, you have this jar file, and then you build a Docker image out of that jar file, and you deploy this Docker image into, say, Kubernetes in Amazon or Google Cloud, wherever your production systems are running. So those steps can also be automated using certain infrastructure as code tools. Say you have some Terraform scripts or Ansible scripts who then push your Docker images and deploy them to your production environments. So if that entire step, series of steps are automated, then we call it a continuous deployment. But most companies or organizations I have come across normally keep it up until release, and the deployment steps to production at least is done manually, like not done manually. It is approved by a human, and then it goes to production, so that just to rule out a real error that occurs and then cascades into a big problem. So the final leg is manually moderated. However, now coming back to what is going on here, so this series of steps can encounter failures. It can take longer than usual, or it can take it can have certain errors. So even if we automate something, that doesn't guarantee that we are performing or doing the best out of it. So we need to measure continuous delivery. That is where the need comes. So you have an automated set of steps. You know that doing this will make your software delivery better and faster. But if we do not have any metrics to measure what we are doing, we do not know whether we are going in the right direction, or if we have any issues in our pipeline scripts, or how often we are failing. Knowing all this helps you to optimize your process and make it better. So there you know that your DevOps practices are helping you, rather than wasting time, like you're doing something because everybody else is doing. So that should not be the case. So you should know like whether these practices are helping your organization. So that is the need of measuring CD, or continuous delivery. Now, it helps you to inspect or to see what is going on with your pipelines, with your delivery system. And then it helps you to improvise. If you are making certain mistakes on the runtime, you can see that okay, this number is too high, so that means I am making some mistakes in the delivery pipeline, so I can fix it before it goes to production. So these kind of decisions can be made on real time when we are measuring our CD processes before it is too late, because we have a DevOps principle like you have to fail fast. That allows you to quickly recover from the mistake you have done, rather than it becoming a very, very big problem later on. So, and finally, measuring continuous delivery helps us to improve. Like we learn from mistakes and then we improve. So how do we measure it, and what do we do then? To measure, when we measure something, we get some numbers. So we get data, and that is very important. So how do we measure it, and what data comes in when we measure our CD pipelines? So there are lots of metrics. Like for example, some people I've seen, they measure number of commits made by the team members. They would say like, okay, in August we had 3,000 commits from 20 people. So, but these kind of measurements create anti-patterns. Like they do not help. You do not know like whether that particular commit really added value to your software delivery. So one should know what exactly to measure. So in all these years of us doing DevOps, like DevOps is not a very old concept. We all did some kinds of automation right from say 20 years ago, but this new this term DevOps is not that old. Maybe from 2005 onwards it has been more popular. So so what we do here is, in order to see the DevOps success, we have filtered out the irrelevant metrics and come upon the real metrics. Like 3 or 4 metrics are there which are very important to tell you about the DevOps success. So deciding on those metrics is very important, and it might differ from organization to organization. And then decide on how to measure, like how to observe your measurements. Like how first you know what to measure, then you try to understand how will you observe your measurements, so that every team member would be aware of what is going on and whether we are on the right path. And then finally everyone should learn how to infer from whatever you see. Say you have a dashboard with the graphs and all which measure your DevOps efficiency, but every team member should be able to do an analysis of that graph and understand what is going on. So these are the questions. So now I'll tell you like how we do that and what are the key metrics. So first of all, there are 4 key metrics that we measure. As I said, there are lots of others, but 4, if you measure these 4, you would be able to gauge that you're on the right path. So, and these 4 metrics are defined by an organization called DORA. I'll come to that in the next slide. So what are those metrics first? First one is the lead time. Very easy. It's the time it takes for like since the code is committed. I'm just simplifying the definitions. You can go through the definitions in the slide, but I'm just simplifying what it is. So right from the time you commit your code into the repository to the time the customer starts using your code as a finished product. So that is the lead time in simple terms. So say we have certain features to be released into production and it started on 1st of August. we started working on that set of features. So that is the start time. We can get this information from our repositories like version control systems. So you get that time from there. And when that particular feature is released and the deployment pipeline succeeds and is deployed into the production, so that is the time when you succeeded to put those push those new features into production. So the time elapsed, like say you did that after 7 days or 14 days after a sprint, or so on. So that would be the lead time. Then is the deployment frequency. How often do you do these kind of deployments? Like there would be multiple teams in a large organization, so that defines what is the frequency of deployments. Now these deployments might also include failures, like some deployments might fail and would have to be rolled back, so that is also taken into account. I'll talk about that. Like there are some other metrics which then cover like what happens when a failure occurs, so what to measure there. So deployment frequency is the number of deployments that you can do. Then we have a mean time to restore. This is also a very important metric. Like when a failure occurs, how much time do you take to recover from that failure? That is called MTTR, or mean time to restore. That tells how efficient the DevOps team is to fix issues, like how quickly they can be back. Because another DevOps principle is like you have DevOps provides speed. So if it provides speed, you have to be capable of quickly recovering from failure so that you're back into action again. And then finally, there is a fourth key that is called change fail percentage. That is the percentage of changes that led to failures. So this we'll discuss in an upcoming slide, but in simple terms, it is you will go through your releases and see which release ended up in failure, and say you did 10 such releases in a period of time. Mostly all these keys are measured per month. So that is also a frame of time. Normally people take 2 sprints if they follow agile practices. So that is 14, 28 days. So mostly we have these monthly reports where we see these changes, because if you do it on a daily basis, it doesn't give you much insight. So mostly these are done on a 30-day period. So the fourth metric is about seeing how many of these changes led to a failure. That means that code went into production, but it had a lot of complaints received from the customers, or there were lots of errors in spite of your test cases being there, and it ended up in a failure. So you had to eventually roll back or do a hot fix. So that percentage is calculated. So these 4 keys give you an insight into everything, like your development team's performance, your DevOps pipeline performance. It also tells you if it was an infrastructure failure that is happening frequently. So it gives you an entire view of what is going on. Now, these 4 metrics were defined by DevOps Research and Assessment Group. This is a group of, like you can say, volunteers. Mostly this was led by Google. Google started this thing, and many other organizations have joined in, like many organizations who monitor, who create monitoring software, as well as people who are in the DevOps field. They join this, including us. Like if you sign up for the DORA, then you will get some mailers every year. They create a survey. Most of you would have got these mails, because even without signing up, I had got this mail. Like I have been getting this for the last 2-3 years. They send you a survey where they ask you, like, do you have automated pipelines? Do you measure these things? What is the frequency of your failures? Stuff like that. And it would take around 15-20 minutes to fill that up. So people around the world send in their insights. From that, they assess like where is the maturity level of an organization, how many organizations are adopting DevOps practices, measuring them, and so on. So based on that data, they created these 4 metrics that should be measured to know your maturity as a DevOps organization and how you're doing with your continuous delivery. So this is very interesting. Like it tells you, like, say for example, your deployment frequency is very high. Like every day you can deploy 4 different softwares into the market. So that means you are very mature as as a DevOps organization. That means your pipelines are not failing. That's the reason you can do 4 deployments in one day. So you have lesser failures, so everything is fine. So you're a high IT performer, stuff like that. If and there are also things like sometimes you will see organization has a longer lead time, but the deployment frequency is high. So that is also risky. Like for example, say you have a longer lead time. What does that mean? You are not doing small iterations. Like you are clubbing a lot of features, putting them together and deploying once after say 20 days. But that is risky because if you have a lot of features going into production at one go, then you will end up with more failures, more uncertainties, rather than if you have small features that are rolled up every day. Then if something will fail, one particular feature will fail, so you can fix that quickly rather than a lot of features failing together. So stuff like that. So these 4 metrics allow us to know about how good we are doing with our delivery. You can all those who are watching, you can go through the DORA website, just look up DORA and you will find even more like use cases about this and how different organizations are using it. Because as a DevOps practitioner, what I have seen, we focus on automation, building pipelines, different tools. We do not focus on the measurements and all. But this, if we can spend like some time for measurement as well, and you get a report of the DevOps out of the DevOps team every month, that helps leaders, like business leaders, to know what what we are adding value into the team. So that helps with the DevOps professionals as well as the organization to know better about how we are doing. Now, we know that these are the 4 metrics that we have to calculate. So how do we do that? So this is a dashboard that can be created from the metrics. As I said, these metrics can be calculated even without these dashboards. Let me just tell you, for example, say you are going to measure the lead time. Forget about the dashboard for a moment. Like say you are going to measure the lead time and you want that data. So you can just go and check your a particular feature when that particular branch or feature branch was created in the repository and when the developer started working, or when did the first commit happen in the code. So we can get the date and time out of that. We have a spreadsheet and we can put it up there, and then we can see when the deployment happened or when the pipeline was triggered and so on. Now, but you might feel like this is so manual, like how can we automate it? So that can be done just by having like we can have a separate script on our Jenkins or any CI tool that you're using that can pick up the first commit date and the successful deployment date from your say you are pushing your code into the Docker registry. So as soon as that code is pushed, it populates a database with the time and date, and it also populates the database with the time from when that first commit happened, and then you can calculate the interval and so on. So to do that, there are some ready-made, like this is one of the pipeline dashboards that I had tried out. So you can go through the README file and the code is here. You just will have to set it up. This was specifically made on a Amazon account, so you will have to use AWS. Otherwise, if you're on another cloud, then you will have to just modify what I'm doing here. And once it is deployed, what happens? It starts up a serverless function and then collects these metrics and creates a dashboard. So that dashboard then shows these kind of data, like these are the different products or software, say your organization, these are different pipelines for different kinds of products, and here you will get the cycle time, lead time, and as soon as you trigger a pipeline, it collects those metrics and calculates how much time is taken in order to deploy that, or how many times the failures occurred, or how much time it took to recover from that failure, and so on. And how do we infer from these metrics? Like, we get all these numbers now on the dashboard or on our spreadsheet. Now, how do we infer? That is also there in this particular readme file. You can go through the inferences. Like, as I said, lead time, it's the time that is taken to for a change to go to production. And this is the main thing, like business cares most about this lead time. So here, if it is too large, that means you are not efficiently doing a continuous delivery, because you're taking a long time to deploy. And the cycle time is how often the software is being delivered into the production. So if this number is less than the lead time, then many commits are being delivered to the pipeline before a previous commit is complete. So stuff like that, you can then infer from these. So for every metric, I have put some interpretations, like how to interpret. And so the most important I have seen out of these four, again, are the lead time and the time to recovery. So these two are very important. So how much time to recover, that also tells about the capability of the DevOps team. And also there is something called feedback time. So that is also very important. It tells how quickly we can identify the failures. Now, this number should be low, as it affects the mean time to recovery, because if you can quickly identify failures, then you can quickly recover it, like work on recovering it. So these are some of the things, like this is how we infer it. And there is a very good project about creating a dashboard from here, because this dashboard is not very elegant. It is just showing you the numbers. But if someone wants to have a very good view, a graphical view of a DevOps dashboard, actually there is no such tool around. Like, there is no ready-made tool around. So we will have to either build it ourselves, or if we are going to go open source. So there is a project by Google called 4Keys project. So I'll also leave the link to that project. This is that project, 4Keys, where we can build dashboards on Google Cloud, and it looks something like this. So here, all these data are put into a database, and this dashboard pulls data from that database and shows it. And it is very easy to deploy. Like here is one shell script, and there is a Terraform script as well. If you look into this repository, go through this README, and you will see this setup directory, and you have this installation guide. So just following that steps, you will end up with a dashboard that measures the 4 keys for your pipelines. And these are the links, so I'll leave it to that. So that was all about like what are the metrics and how you measure them and how you build dashboards out of it. So I'll then put it back to Tom, and we can have questions.
Yeah, Lots of good questions here that I have. I was taking a lot of notes, so but you
Right.
had a very interesting presentation there. One of the things I wanted to ask you about, and I see this, we have all this movement in DevOps and things, but there's still, you still find pockets of
Yes.
manual processes. Why do you think there's still some of these? Because you even alluded to this a little bit in your presentation, that there's still some things that we have these manual processes. Why
Right.
do you think that is?
Yeah, that's a very good question. Actually, as I said, like when we deploy, still we have some moderators who would see whether this should go into production or not. So these pockets are still there, just to because DevOps and site reliability, they should go hand in hand, but the principles are different. DevOps says like we need quick changes, fail fast. Reliability says no changes. It should be like everything should be stable. So if we are going to do, and in DevOps we say, okay, lead times should be slower, and you should have a faster deployment frequency. Put 10 software, like 10 versions every day, 10 builds. But reliability says no. So when DevOps and SRE teams have different fundamentals, then in order to balance that out, we still have this moderation. But there are ways out of it also. We have something called canary deployments. Say you go all out all out to production automated, but when you deploy to production, you can deploy a smaller percentage into production and see how it goes for a couple of hours or days, and then based on that increase the percentage. So these can be done. But what I have seen, like I have worked in very small organizations as well as bigger ones. So I have seen in smaller organizations, it's not very practical to have these blue green deployments or canary. Why? One is the budget. Like to do a blue green deployment, say you will have to have some extra servers where you put in the new code and watch for a few days, and if it goes well, then you come back and deploy. But in for larger organizations it's fine. For smaller, they would not have the budget to have those extra. They say, okay, you test it well and put it there. We don't want a new server or anything. So there you have to do that manually and see how it goes. But yeah, this applies to large organizations. It's good. Like if you have a good budget, it can be completely automated as well.
Yeah, that's good. And one other thing, because you talked about measurement, and I think this is one of the things where I see, and you've probably seen this too, where some organizations just kind of get paralyzed because they don't know what to measure. I know you talked about the DORA measurements, but it seems like and you probably see this too, as you read online, there's lots of noise, but I would agree the DORA, but why is there people is it that they're paralyzed, or why do people not measure these, DevOps pipelines?
Yeah, because the thing is, not DevOps hasn't matured. I feel like it hasn't come to that level of maturity. Like even me, I do not know. Like I have been working. I suddenly realized that I became a DevOps engineer from a system admin. Like I had been dealing with server for 15 years or 20 years maybe. From 2000, I have started working on servers and all that. And I was doing these kind of automations even before the DevOps term came in. But suddenly, say 2011, 12-ish, then I started saying, okay, I'm a DevOps guy now. So that's how it is. But still, the practices have not been completely optimized. So some of them still feel like it is about using newer tools. It is about Kubernetes, containers, and all that. But in the end, it is not about how we are doing it. It is about what to how do we standardize these practices and know that it is actually adding value. See, everyone doesn't need Kubernetes. Like if your organization is just having a small application or a website, you do not need to host that on a Kubernetes there. So, but most people would now start containerizing even their databases. So that is not needed. Even when we are doing Java, I mostly deploy Java, so I would stick to that. The jar file itself is you can say it is a virtual JVM. It is isolated. So containerizing is good, but on a larger scale where it is actually needed. So that's how it is. Like I still feel it needs to mature, and then we can, and this measuring is a sign of like you have reached a level, now you're measuring, so you have matured as a DevOps organization.
Yeah. Excellent. Excellent. I want to thank you, Prashant, for spending some time and your valuable time here with the group of us here at the DevOps Online Meetup. I do want to put in a plug for next month. So on September 14th at noon Eastern, same time, we're going to have War Stories, the 3 good practices never seen in the wild. So be watching for that. I want to thank everyone, especially you, Prasanjit, for sharing your time. Thank you so much.
Thanks, Tom. Thank you so much for having me.